So let's get on with our program tonight called Gradients in Birds and Nest Webs in the Eastern Cascades. Kurt Trzynski is a professor at the University of British Columbia and the principal of Trzynski Consulting. Kurt conducts ecological and environmental research into the effects of human activities on biodiversity and ecosystem function. And Steve Shunk is going to talk also, and most of you know Steve. He's been a driving force behind the Dean Hale Woodpecker Festival, and Steve is an accomplished professional naturalist and the principal of Paradise Birding in Sisters, Oregon. So let me turn it over to Kurt. And
thanks, Gordon, for that introduction. And it's great pleasure and honor to be here. I feel at home amongst birders, and an opportunity to tell you a little bit about what Steve, Matt Orr, and I have been doing over the past couple of years. So some of the research we've been doing on birds, principally two studies, one on the elevational gradients of birds, and the other is on a new study on the nest webs that woodpeckers create. So yeah, it's been really great to be a part of this study, and I wish we could meet in person. I look forward to those days to get to know you, and perhaps we'll get to know you better this spring and see you out in the field. Okay, so we'll just jump right in. Gordon, can we all see that?
yeah, I can see it. Looks good.
And as is custom, if you could mute, that would be great, and help with the talk and less feedback, and then we'll open it up for some questions towards the end. I will, however, invite my colleague Steve Shunk to jump in at any time. So Steve, if you want to clarify something, then just say, hey, Kurt, and we'll do it informally like that. So as I said in our introduction, we've been conducting two studies. Last year, we made a really strong push on estimating the distribution of birds along an elevational gradient in the Sisters Rangers district from Billy Chinook as the lowest elevations all up through the Sisters Rangers district to the highest elevations at Tam MaCarthur Rim. So that's the motivation behind that is to understand first where the birds are and how the community is shaped in the region, but also lay down some baseline data to understand the effects of climate change. So a one-year study, you can't determine the effects of climate change, but it's really these studies that provide the baseline for comparison. So ecologists have been long interested in gradients, elevational gradients, but gradients of all sorts. Species distribute themselves along temperature gradients, latitudinal gradients, gradients of moisture, all sorts of environmental gradients. And the elevational gradient has been well studied over many years. And one of the most obvious things that happen along an elevation, as this graph is showing, is that as you go up in elevation, the temperature decreases. And it's somewhat like moving north. All right, so for every 3 degrees Fahrenheit, or for every 1,000 feet increase in elevation, you go up a mountain, it drops about 3 degrees Fahrenheit or 2 degrees Celsius. And temperature is not the only thing that changes along this elevational gradient. We all know as we drive up the mountain, we can see the habitat changing as well. So temperature decreases as we increase in elevation, but precipitation is also higher in the mountains. Okay, so as you go up, even on on this side of the Cascades, the drier side, the East Cascades, as we go up in elevation, there's typically more precipitation. So these graphs are showing in the colored line the decrease in temperature and the increase in precipitation. And then this is the expected change with elevation for the number of species, or something, species richness. So that's one way we measure species richness, is just simply the number of species. So at the lower elevations, we expect the species richness to be highest, and then at the highest elevation to be lowest. But we have this, if species were mostly affected by precipitation, that we might expect a different pattern. Now, productivity is a word that describes how much vegetation growth there is in an area. And vegetation growth is strongly linked to both temperature and precipitation. So because we have a decreasing temperature with higher elevations, and we have increasing precipitation with higher elevations, we might expect that the highest productivity of vegetation would be at a mid-elevation. That's what this green line is showing here. And as we go up the mountain, we have smaller and smaller bands of vegetation, because, you know, if we imagine they're not shaped like a cone, but a stereotypical mountain may be shaped like a cone. And as you go up, there's less subalpine habitat than there is the lower habitats like riverine or estuary or various other lower habitats. So as you go up, we have less habitat, we have less alpine habitat. So habitat area also affects species diversity. So there's a lot of things that affect species diversity as you go up in mountains, and that might affect the distribution of birds. So I think it's important to point out some of the previous research that this research is based on. And that we're only able to advance science based on, really good science that's been done in the past. And Ernst Mayr, a very famous evolutionary biologist and ornithologist, and Jared Diamond have studied the birds of northern Melanesia and Southeast Asia. And they did very detailed studies. Jared Diamond did his PhD in the early 70s in Princeton. And one of his important studies I'm pulling up here is he estimated birds along an elevational gradient in this island, volcanic island just off of Papua New Guinea. And what we can see here on the right is a list of a bunch of species. Okay, so and then on the top we have altitude in feet. And the black bars indicate the ranges of these various birds. And what you'll notice is that some of the birds are found in very narrow bands along the coast, these short little bars here. And some birds, quite surprisingly, are found all up and down the mountain, right from the coast up to the summit at 6,000, just a little over 6,000 feet. And then some of them are in these bands in the middle. Right? So, and Jared Diamond spent a lot of time trying to understand the distribution of these birds and what might cause their patchy distribution amongst these islands, and very early studies of island biogeography. What he found in this particular study is that a decrease in the number of species as you go up the mountain. So we have altitude in feet on the x-axis, number of species on the y-axis, and the most species-rich areas, the areas with the highest number of species, was along the coast. But as we went up the mountain, the number of species dropped until you got up to the summit, where there were only a handful of species. Okay, so this is the kind of stuff that's been done in the past, and was our major goal for describing the elevational range limits of birds in Eastern Cascades, setting out this foundational data. Now, what's interesting is that what can be done after that. So Benjamin Freeman was a postdoc at UBC while I was there, and I didn't get to know him well, but I met him and saw a couple of his talks. Benjamin and his wife Alexa went back to these sites 44 and 47 years later, so somewhere around 2012, and they repeated the study, and they wanted to see if things have changed in 40 years. And what they found, sorry, somebody might have their microphone on. What they found is that the birds moved up, their ranges moved upslope in 40 years time, that on average, birds moved up 113 meters upslope, the slope of Mount Kariemui, I guess you would say, and Kakar Island, they moved up 150 meters upslope, their ranges. And the estimates of the temperature 40 years ago between now, that there's been an average increase of 1 degrees Celsius. And that's about what you would expect, 100-meter shift with about a degree change in temperature. And some biogeographers would also know that 100 meters or 1 degrees is something like a temperature change for about 100 kilometers north. And it was 100 or 1,000, but there's a latitudinal similarity that you can make the similar predictions for changes in latitude as well. So that was the value. If we go back, this is the baseline data, and then you're able to go back and see what's happened. Okay, and so that's why these legacy data sets are so important. And we're hoping to create a legacy data set here in Eastern Cascades, so we have this point of reference. Now, Ben Freeman also went back to a bird study in Peru. So you can see this part of Peru here, not too far from Cusco. This green area is the Amazonia region, and the orangey area is the mountains. They found this, they went back to this mountain ridge and repeated a survey there to see if something similar had happened. And you see up here in the upper graph, we have this number of species. So the species are just getting codes, 1, 2, 3, 4, up to looks like 100 or 120 species. And on the y-axis, you have elevation. And the bars indicate where those birds were found. Now, the gray bars were where they were found in the 1980s. So this particular species, it didn't change between the 1980s and now. Its elevational range limits were approximately similar. But these other species where you see these green bars have expanded their range to higher elevations, okay? And where you see the red bars over here, those species have contracted. So this species, whatever, I'm just gonna make it up, 65, used to be found at almost 500 meters elevation, but now is only found at, greater than 700 meters elevation. And it's not every bird is moving as expected. Some actually contracted in their upper ranges and some expanded in their lower ranges. But overall, this graph is showing that birds are shifting their ranges upslope with time, with climate change. And so this is often called the escalator to extinction. So you can go up a mountain, but you only can go so far. So this visual graph here is showing a mountain in a conical shape, which is actually kind of similar to the ridge that they studied in Peru. And it shows the distribution, the elevational range limits of 3 birds in 1985. And this sort of green band, this brownish band, and this bluish gray band. And then when they went back in 2017, they found 2 of these 3 birds had moved upslope, but the one that had been around 1,300 meters was no longer there, presumably locally extinct. Whether it's extinct globally, I don't think so, but it's no longer found at the top of the mountain as the habitat has changed and the birds have adjusted. So that was even less, 85 to 2017 is even a shorter time frame, but they have found this this escalator to extinction to be possibly true. They supported this hypothesis that birds will either move up mountains or north, or they'll go extinct. Okay, so that's mostly what we did last year. It's entirely what we did last year. And we'll talk a bit about that. I want to throw this in because we're combining, I'm combining a couple of different studies in the studies we're doing here in the Eastern Cascades. So there's been, you'll see in the next couple of slides, extensive research on woodpecker and secondary cavity nester communities in central British Columbia. And I've been involved with that team over the past 5 years or so. And they collected a lot of data, and I'm analyzing and I'm now publishing some papers with them. And one of the things they found is that areas, these are each sites, study sites of 10 to 20 hectares each. Study sites with more woodpecker nests had more secondary cavity nests. Okay, so may seem obvious, but it's difficult. It's important to show. But places where there's high woodpecker activity supports a very rich secondary cavity nester community. And as my study shows that I won't talk about too much, is that there needs to be a constant supply of new cavities for this to occur. Older cavities are used less, and of course they fall down and need to be renewed. And this is also true. So that was a woodpecker nest species richness relationship. It's also true that where there are sites with more woodpecker nests tend to have more secondary cavity nests as well. So more nest and more species of secondary cavity nesters. So some of the things that we can say from the studies that we've done is that elevation, some previous work that I showed you by Ben Freeman about elevational gradients in the tropics, that birds are moving to higher elevations. And in British Columbia, woodpeckers maintain the diversity of secondary cavity nesters in BC, and woodpeckers are important ecosystem engineers for those forests. So these questions don't come from anywhere. They come from previous studies, and that's kind of the point of that review. And we don't have similar studies in our Eastern Cascades region, ecoregion. So we're asking, do similar relationships occur in Oregon? Are there more secondary cavity nesters where there are more woodpeckers? And, you know, will that change with elevation? You know, we can do that over space. So if we go up the mountain, are there more or less woodpeckers? And does that mean there are more or less secondary cavity nesters? And then eventually, maybe 10, 15, 20 years later, we can make the comparison over time. Are these relationships changing over time? And so, of course, you all know that Eastern Cascades is a very rich, one of the richest places for woodpeckers in North America, with 11 different nesting species. So that seems like it's a really great place to ask these questions. And of course, we have this wonderful elevational gradient. So our first proposal that we put in 2019 and executed in 2020 was to estimate the elevational range limits and interspecies correlations in bird diversity and abundance along an elevational gradient in Central Oregon. And we have my colleagues, Matt Orr and Stephen Shunk, of course, and this was funded by the Eastern Cascades Audubon Society. So thank you very much. What we did is we aimed to describe the elevational distribution of birds, never been done in a rigorous way. There are lots of anecdotal data, but we wanted to do it in a systematic way, provide baseline data for future studies of climate change, test for the co-occurrence among species. So are there more secondary cavity nesters where there or more woodpeckers, as was found in British Columbia. And then secondarily, tests for some of these habitat effects on species distribution. So given previous research, we would expect that bird communities would move to higher elevations with climate change. We might expect that if woodpeckers move, secondary cavity nesters will move as well. We don't know yet, but that's a hypothesis. And we would also expect that sites with more woodpeckers would have more secondary cavity nesters. So we don't know these things, and we have reason to believe them to be true, but we're collecting the data to find out whether that is true. So we start with what are the current elevational range limits. So it's a picture of me, my socks, and a giant map of the Sisters Rangers District and all the different vegetation types. So there are lots of roads, as you know, and lots of different vegetation types. And on top of this is another map, of burn history. So we have a very complicated pattern of vegetation and fire history, creating a very diverse mosaic of vegetation at different ages and burn severity. So our task then was to set out some point counts in this very diverse area to estimate the elevational range limits. So we laid out 50 point count stations along 5 different routes where we would drive. This one is basically just outside of Sisters somewhere around where my toe is here. And this route, we would drive up to Tam MaCarthur Rim and do point counts along that route. Now, each point count, we would hike 100 meters off the road to reduce the effect of the road and noise traffic or any effect that the road might have on habitat and bird distribution. And so there's route, 1, 2, 3, 4, 5 routes. And you can see one of them here is all the way down here by Lake Billy Chinook. So that'd be our lowest elevation there and our highest elevation here. And that's about a range of 620 meters to over 2,300 meters, a range of 1,700 meters. So we went back to these point count stations 3 or 4 times, and we counted all birds and small mammals seen or heard, and we did 6 minutes of passive listening, and then 10 minutes of woodpecker playback calls, where we would play a species for 30 seconds and then listen for 30 seconds and then play another species and so on. So it's the total census period is 16 minutes. Anything we saw or heard during 16 minutes. This is just a visual of the vegetation types, which you all know so well from very dry, desert open vegetation types down around Billy Chinook to the quite common ponderosa pine forests at different ages, different burn histories, and different management practices with thinning and so forth. Alpine areas, all the way up to the Krumholtz and at the tree line are a little bit higher. So this is the major result of 2020, the elevational range limits for about 75 species of birds. I can't remember exactly, but around 70. So in 2020, we saw identified during our point counts around 102 bird species and 4 mammal species. And there's some species codes. It'd be a little small here, but there's species codes here, 4-letter codes on the x-axis and elevation in meter on the y-axis. And these are what you call box plots. So the little black bar is the median elevational range. So right now I happen to be over the lazuli bunting. And the bunting occurs from about 650 meters is the lowest we saw it, It's averaging around, I don't know what that is. We look over there, about 900 meters is where their average range is. And then you can see they were found to around 1,400 meters elevation. So, and I've ordered them from the species that had the lowest median elevation to the species that had the highest median elevation. And these won't come as too much of a surprise, but at the highest elevations, we saw Clark's nutcrackers, spotted sandpipers, varied thrusts, golden crowned kinglet, black-backed woodpecker, mountain bluebird. And at the lowest, we had osprey, Billy Chinook, American kestrel, Bullock's oriole, California ground squirrel, and Lewis woodpeckers, western kinglet, yellow-breasted chat, rock wren. So you can see how the species are changing with elevation. And one of the messages here that I think Steve pointed out to me the other day is that, most of them are found at this, 900, 1,000 to 1,200 meter range. Most of the bird diversity is found, most of the birds are found right in this middle range. So I also put out temperature data loggers, and there's the theory, temperature decreases with elevation. And if you remember what I said before, it was about 2 degrees Celsius per 3,000 feet or 1,000 meters, right? I think I maybe got the number wrong there, but yeah, it was 2 degrees Fahrenheit per 3,000 feet, or 3 degrees Celsius for about 1,000 meters. So these are mean daily temperatures in July. So we measured temperature every hour for every day of July, and then we averaged them. And you can see at the lowest elevations, around 600 meters, the average temperature was around 22 degrees Celsius, and it decreased. And it decreased at about half a degree Celsius per 100 meters. So that's, it's a bit different than theory, but it's what happened. And I remember my theoretical graphs would say we expect species to decrease with elevation. Well, we kind of found that. Bird species richness here on the x-axis, elevation in meters on the y-axis. But what we found is a little bit of a hump where at the lowest elevations around Billy Chinook, we had a few less bird species. Bird species richness is in the solid line, in this dashed line. Is that right? Yeah. So no, it must be this solid line here. So we had about 40 species at the lowest elevation, and it didn't really rise much. But it rose maybe a little to around 1,000 meters, and then it decreased. So this is as expected. So I'm plotting two things, and the dashed line would be the number of birds that we actually observed at a station. So at some stations or some elevational bands, we saw 20 species, and others we saw 30, and so forth. We find a little more of a hump shape with the mammal species. Now we only have four mammal species in the data set, small mammals like yellow pine chipmunk and California ground squirrel, Douglas squirrel. But the highest species richness was occurring at about 1,100, 1,200 meters, and then they decreased as well. So, as I said, there's some particular interest in the relationship between woodpeckers and secondary cavity nesters. So the question then is, are woodpeckers doing the same thing as all the other birds? And it looks like they are, that the number of woodpeckers and the species richness of woodpeckers in these solid lines increases to about 1,200 meters. All right, so you're about 1,000 meters. So 1,000 meters is just around the Sisters elevation, a little bit higher there, just as you're driving out of Sisters, is where we find the most woodpeckers and the most woodpecker species, maybe even a little higher as you get out there. And then it drops off. Woodpeckers drop off with elevation, both in their abundance and in their species richness, quite rapidly in their species richness. So 1,200 meters, we have about 7 species of woodpeckers that we're seeing regularly. Could probably find more if we search for all of them, but the average is around 7. And then by the time you get up to 2,000 meters, that's at the alpine levels of the Tam MaCarthur Rim, you really are seeing 0 or 1 species. I think the only species I saw up there was the 3-toed woodpecker. Now, the other part to the story then is our secondary cavity nesters doing something similar to woodpeckers, because they rely on woodpeckers for the cavities they create. So the tree swallows and bluebirds can't make their own cavities. They need woodpeckers' help. And it does look like their species abundance, the number of observations, and the species richness is following those of the woodpeckers. So at higher elevation, secondary cavity nesters decrease in abundance, and they also decrease in richness. So it's saying that there's a relationship between the two. And this is a graph showing the relationship between woodpecker density and secondary cavity nester density. So sites with no woodpeckers have no secondary cavity nesters, but sites with woodpeckers have more secondary cavity nesters. So there's a lot of scatter here, but this is a significant relationship, this line statistically. So the number of secondary cavity nesters increases quite rapidly up until about 0.5 woodpeckers per hectare. And then it's quite variable. Other things must be going on as far as territoriality or vegetation effects. So there is that important correlation that we could kind of see in the other graphs that we can see in that graph as well. Okay, so our sites, our point count stations were not evenly distributed across these different vegetation zones. And that's partially because it's hard to get to the lowest elevations. It's really hard to get to the higher elevation. And it's easier to get into these mid elevations where there's lots of roads. 1,000 to 1,200 meters provides a lot of opportunity for birding. So our proposal for this year was to bolster and strengthen the data set from 2020 by going out and specifically trying to increase our sample size at the lowest elevations, do some point counts along the Metolius River, and then bolster our point counts at the highest elevations. So this is mostly, it's hard to drive much higher than 1,700 meters. So 1,700 meters is where the road to Tam MaCarthur Rim, how it's paved, and when it turns to gravel, that's around 1,700 meters. And that's a lot higher than Santiam Pass, for example, which is somewhere around 1,300 or 1,400 meters. So we'll be doing some more point counts along that gravel road and along the trail up Tam MaCarthur Rim to help our understanding of the elevational range limits at the species at the highest ends of their ranges, and also along the Metolius River at the lowest ranges. So we've added 10 new sites at the lowest, and we're going to add another 10 at the highest. So some conclusions, we now have some baseline data on bird distribution, which can be used for future studies of climate change. And we have some interesting correlations between woodpeckers and secondary cavity nesters that seems to support the work that was done in British Columbia. So that's exciting. I think that's something that needs to be out there, because the world needs to know how important woodpeckers are for maintaining the biodiversity of secondary cavity nesters in North American forest. So we're also, as I just said, collecting more data at high and low elevations. And this last part is one of our main focuses for this year, and hopefully for the next few years, is develop a nest web for Eastern Cascades ecoregion. So you might ask, well, what is a nest web? Well, a nest web is like a food web. A food web is where predators eat prey, and predator or prey can be put into a diagram and linked with a line or an arrow. With a nest web, it's the same idea, except the lines are connecting cavities. So I'll just walk you through this. This was done by Kathy Martin, early work in 2004. She was the first one to publish this concept of a nest web, and this work done in British Columbia. At the bottom here, we have tree species, and you can see highlighted in yellow that the aspen was the most sought after tree, the most used tree, where they ended up finding nests in 2,400 aspen between, what does it say here? Oh, between 1995 and about 2002. So they did a lot of nest searching. And there was a few in these other species, cottonwoods, fir, pine. And then you have the excavators, the woodpeckers. And then we also have a category for natural decay. So species will nest. Trees do create cavities just through decay, just through heart rot. And birds do nest in those, and they aren't created by woodpeckers. In our ecoregion, that's a rare occurrence, but in other parts of the world, it's quite common. In fact, it's the dominant form for cavity nesters is to nest in decay-formed cavities. That'd be true in Argentina. One of our colleagues, Christina Cockle, does work in Argentina. So one of the first things in these numbers under here are the number of nests found of these various species. And the first thing that I'd like to point out is that for British Columbia, and presumably for here, but we'll find out, is that around 95 or 98% of the nests of secondary cavity nesters were found in nests created by woodpeckers or primary excavators, and not in the decay formed. You create the same graph for Argentina, and most of the secondary cavity nesters are in decay formed cavity and not in woodpecker cavities. So it is something a bit unique that the secondary cavities nesters in North America have such a heavy reliance on woodpeckers for their homes, their nest. So we can see that most of the cavities they found were in aspen. They were created by 7 different woodpecker species, including the downy woodpecker, black-backed, three-toed, hairy, red-naped, northern, and pileated. And then if we look at the strength of the line indicates the number of nests, and most of the nests were created by northern flickers. So it's an area where there were a lot of northern flickers that created a lot of nests, and then they were used by the bushy-tailed wood rat, the mountain bluebird, the European starling, northern saw-whet owl. You can see the lines there. So this kind of diagram, emphasizes the interrelationships of these trees and bird species, but it also helps one visualize like what would happen if the northern flicker no longer existed in this forest. Well, you would see a collapse of the ecosystem, and many of these birds would have to shift to other nests or decrease in abundance, have less nesting opportunities. So this is the nest web for BC, and there's been a few others produced around the world. One for the Florida, red-cockaded woodpecker, but the entire ecosystem in North Florida. And also I recently saw a nest web for the woodpeckers and secondary cavity nesters in India. So it's something that is catching on, but it's quite data intensive. And so we're interested in doing this for Central Oregon, and excited to get out there and hopefully get you all involved in searching for woodpecker nests. So we're starting out by looking just for the woodpecker nests this year And then we go back the next year to see whether they're used by chickadees and bluebirds. And we follow them for hopefully 3-4 years to see how many of those woodpecker nests are used and who uses them. And here's a nice list of secondary cavity nesting birds and a couple of mammals that could potentially use these nests and help us create this nest web. So bottom line is that Steve and I will be out doing point counts to finish up our elevational gradients work, and we will be out looking for woodpeckers. In fact, we were out just a couple of days ago searching for nests, and we're interested in anybody who discovers a woodpecker nest within the Sisters Ranger District, including Camp Sherman and the Metolius Preserve. If you could tell us about that, and then we can go back and take some measurements and help build this nest web. And I think that's all I have. I'm happy to take some questions.
Yeah, I had a question for you. Flickers seem to be quite productive building these cavities. We have a lot of flickers, and I think a lot of us have flickers around our houses. How do you find a flicker nest?
Steve, you want to jump in on that?
Yeah, you this time of year, you watch the flicker, you just keep watching it, and it will take you to the nest eventually. You know, obviously give it some space. But these birds this time of year will take you right to the nest. Flickers are a little bit harder than some of the other woodpeckers because flickers don't feed their young directly, which means food in the bill to food in the bill. Flickers regurgitate. So it's a little harder to tell when a flicker is carrying food to the nest. So finding a flicker in a cavity doesn't always mean that's an active nest cavity. They could be roosting in that cavity, but we still need to know that information. We want to know which cavities you're finding, and then we can follow up on it so that we can confirm later that actually that nest is being used this year. So follow the birds to the nest. Just today I was driving out of the Metolius Preserve, and a flicker popped its head out of a nest in a juniper right by the road. And you know, it's really just about watching the woodpeckers. If any of you have ever participated in a breeding bird atlas project, this is very similar. What you do is you just pay attention to behavior. You watch the birds, you hear them drumming, you watch territorial activity, you watch them dancing around the tree together, and you know that you're close to the nest. And you just continue to watch them, and eventually you'll find the nest. It's really it seems logical, but it's very satisfying to be able to follow those birds and discover a nest site like that. And one more thing about flickers, you notice the abundance of flickers up in British Columbia. I think one of the things that we'll find here, one of the hypotheses we have here locally, is that the Harries play a little bit bigger role here than they might have played up north. Flicker abundance up north tends to be greater. And though we have lots of flickers, one of the interesting things about flickers is they tend to take an old cavity that was maybe made by a hairy woodpecker and expand that cavity and reuse it. So this is something that we're also trying to document. If we can find a flicker nest, we can tell by looking at the quality of the wood around the nest cavity whether that's something they freshly excavated or whether they've taken a cavity and opened it up.
I just saw a comment by Elise, so thank you for that question, Elise. We're not ruling out any tree species yet. The graph I showed you was for tree species in British Columbia, and I guess in that particular area, British Columbia, they didn't have junipers. But yeah, we're not just. We'll find a lot of cavities in aspen. We know that, but we're expecting to find them in all sorts of fir species and ponderosas as well, and hopefully junipers. I'd love to see a cavity in a juniper.
And we'll probably see juniper nests in the. Sorry about that. We'll probably see juniper nests in the Lake Billy Chinook region and the lower parts of the Metolius. There's not a lot of juniper on the Sisters Ranger District. There's a lot of juniper outside the district. And as you know, the juniper pine interface kind of defines our region. And as you go east, you get more juniper. And of course, you're going to have more juniper nests. And we have to draw the line somewhere. And so we're using the Sisters Ranger District boundaries as kind of our study area.
Yeah.
And we're willing to go, to areas adjacent to the Ranger District, as long as we feel like that's part of the same habitat zone. And so, we will probably find some juniper nests, but the abundance is going to be obviously at the lowest elevations will be in ponderosa pine. And then as we get higher, then that diversity, and the aspens. And as we get higher, the aspens will stay high, but then we'll add in Douglas fir and true firs and spruces and other trees at other elevations.
So, Mary, do you have your hand up?
I just wanted to.
Well, Mary, you can always type. You always can type your question in or your comment. We'd love to hear from you.
So when I go through my neighbor's yard with binoculars on and they ask me what I'm doing, I'll tell them Steve Shunk sent me.
Yeah, that's fine. And then I'll tell him Kurt told me to tell you.
So I noticed
The main thing that we're looking for this season, you guys, is to get you out there and help us find the nest. This is our primary objective with the nest web part of the project. And we can't do it on our own. There's only so many days in the week and we aren't available all those days. And, we're all doing our different parts of the study. And you guys are the ones getting out there. You're the ones that are out birding. And we need your help finding these nests. We'd really like to find 50 nests this year. And you notice that British Columbia study had hundreds of nests. And we'd like to work toward that, but we're kind of trying to set the bar to something reasonable for this year. And if we can find 50 woodpecker nests this season, we'll be really very happy. And then we'll be able to follow those 50 nests next year and add some new nests. So what we really need you to do when you're out birding is just spend a little extra time. Instead of just identifying that you've seen a flicker or heard a flicker, maybe follow that flicker around a little bit. When you find a blackback, spend a little extra time with it and follow it and see what it's up to. Everybody except the flicker and the pileated are going to be very obvious when they carry food to a nest. They'll have those big grubs in their mouth. If they don't eat it right away, they're taking it to somebody else. So when birds are hungry and they're eating on their own, they eat it immediately. But anytime you see a bird carrying food, you know that they're going toward a nest. So follow those birds. Use your phone if you know how to do that, or if you have a GPS device. Take a reading, even if it's close to where you found a nest, and send those coordinates by email to Kurt or me. And then what we can do is we can follow up as we get a little later in the season and just do the later confirmation and take some data from those nest sites.
Yeah, so hopefully you're excited about the idea of a nest web. It's a very unique thing. It may not kind of seems like obvious for this area, but when you start looking at bird communities around the world, you start to realize some of the differences. And so I think this is a really great study to put into that world comparison puzzle. So when you're out there, we all like to bird, but if you're out there spending a little bit of extra effort, it really helps us build this network, which also this nest web, which is a strong point for conservation arguments, really. We'll get to the question in a second, but to follow up on what Steve said as well, I don't know how many, we haven't done this yet, so we haven't got a good system yet for gathering information as it comes in. And I was just thinking about that because Steve was out today and he's like, oh, I saw one over here and I saw one over there. And I'm like, oh my gosh, like, am I going to get 30 emails a day or 10 emails a day, and I have to sort through them and figure them all out. And 10 isn't so bad, but I am starting to think about maybe trying to make a system where like a Google Doc or something where we could go and record these. And I want to talk about whatever you want to talk about, but I just let's see. I just wanted to share this really quick. Is I thought I could I've just made this right before. It could be like 20th of May at 10:05. We saw woodpecker. I don't know. Where did we see it?
Calliope Crossing.
How do you spell that? Calopie.
Close enough.
Right. And then if you have a latitude or a longitude, if you have a GPS, and then the thing is we're going to need a lot of description, right? So is it, how do we go to say?
Like first Aspen Grove north of the crossing and on the south side of the creek. Something like that.
So if you don't have the latitude or longitude, about 100 yards in, or something like that, and we don't need a lot, but we need to get into the right neighborhood, right? So there's going to be a point where you may just see the bird, and you could say just saw the bird feeding, or observed carrying nesting material.
Or carrying food. Maybe you don't have the time to follow the bird all the way to the nest, and you've got a few minutes and you just see the bird carrying food. That's important. Most of these birds have relatively small breeding territories, and so some of them can fly quite a ways to their nest, but in general, if you see a bird carrying food, it's going to be relatively close to the nest.
Yeah, so I could put another sheet in here about the kinds of observations we're looking for, like carrying food, carrying nesting material, or saw entering a tree cavity hole or whatever, So we can give you a few tips about some of the things we're really looking for, but what'll happen, it'll be like, oh, Steve will be like, oh my, okay, this is awesome. We need to go see if we can find this. And then we'll go out there and spend more time searching. And then what'll eventually happen is we'll mark the tree with the tree tag number, and then we'll give the cavity a number, and then we'll go back next year and see who's using it. We'll do a few measurements like the tree species, tree DBH, maybe cavity height, that kind of stuff.
So I got a question on the location. Do you want these areas to be just on public land, or is it okay to tell you about some cavity in a residential area that's on someone else's property?
Yeah, I think that's where we're kind of drawing the line here. There's access issues. Right now, it's just within the strict boundaries of Sisters Rangers District. But also, I mean, if it was like in the middle of Camp Sherman in a public space, we would take that, right? But if it was encroaching on somebody's private property, then maybe we wouldn't want to go there. Almost certainly we wouldn't want to go there. So, and there's also, we are collaborating with the U.S. Forest Service, and they're providing us with the GIS support, the maps. So we're able to relate our observations to more scientific data when it's on the Forest Service land.
Right. And I should also say just briefly that the Forest Service is a very important partner here, and we wouldn't be able to do this without them. They have done a tremendous amount to help make this happen, and just like East Cascades Audubon and Oregon Birding Association have all have helped fund the project. The Sisters Ranger District has provided quite a bit of in-kind work to make this project successful.
Totally.
And the next step is you folks. We need your help. We can't collect all this information if we don't have enough nests. And we really got the more nests we have, the better data set we have, and the more information we can get.
Yeah. Any observation on a woodpecker is valuable at this point. And I think what I'm going to do is clean this little Google Docs sheet up and give some notes about what we're looking for, and then maybe we could spread it around amongst the ECAS users. Oh, one thing you forgot though, Steve, don't forget Oregon State Cascades is also a very important player as well.
Correct.
Matt Orr I think is in our audience, and we've had students involved collecting some of the vegetation data, and Matt's been very important for providing scientific feedback on the project and helping us administer the funds that the Oregon Cascade and Oregon Birding Association have given us to support this project. So is there anything, I guess there was